Okay, in trigonometric integration, we will be dealing with the types of integration problem where we have any trigonometric function raised to any exponent. Okay.
Exciting.
Yeah, so any trigonometric function raised to any exponent. First, we will start with sine and cosine. Okay, we're going to start with sine and cosine. So we will start with a very simple problem. Let's say we have sine raised to the power 5x and it is multiplied by cosine square x dx. This is product of two trigonometric functions. Okay. Now, whenever we see the product of two trigonometric functions, it immediately comes to us that let's use substitution. Okay.
Right.
Now, the tricky part is whether we should substitute sin x as my u, or should I substitute cosine x as my u? How will we decide that?
Well, if I'm thinking about it this way, I'm trying to like make it very easy to like simplify and cross everything out. So the derivative of sine is cosine. No, yeah. And the derivative of cosine is minus sine. So in this case, like if I were to say, okay, if my u is sine, my u prime would be just cosine. The only problem is that in this case, even though I have cosine is the same thing, I'm not really sure that can be simplified. But then if I had cosine, actually if I had cosine and minus sine too, I think in this case I would put u as sine x.
Okay, so let's try both the methods. Okay, what's the worst that can happen? We'll get stuck and then we'll choose.
Oh wait, no, I'm sorry. I realized something.
Yeah.
U equals cosine x. That would be minus sine x. I'm substituting that. I have sine x minus sine x, so that's gonna work better.
Yes, that's gonna work better, and this one will not work better. But why this one will not work? You should understand why this will not work, and the reason is that I'll explain this to you. Let's just take u as sine of x because I want to show you the derivation of this type of problem when you have sine raised to ax times cosine raised to bx. This is the integral that we are dealing with. So what do we do? What kind of substitution we make? That will just depend on these exponents a and b. Okay, so let's just take sine of x as u. So du becomes cosine of x dx, and dx becomes du over cosine of x. Dx becomes this. So let's now simplify this. So this becomes u to the power 5 times cosine square x. Dx is this, du over cosine of x. So now what is happening?
And then that's going to cancel. It'll be like cosine x.
Yes.
And u.
Yes. So we get u to the power 5 times cosine of x. Now we have to bring this cosine of x in terms of u, right? So what that will be? Cosine of x is square root of
1 minus x.
1 minus.
1 minus.
Yes. Cosine of x is square root of 1 minus sine square x. So our sine is u. So we get 1 minus u square. So that's what we are going to do here. U to the power 5. Actually, it's plus and minus. So this times plus and minus square root of 1 minus u square du. Now this
I can
is,
see why this is complicated.
yes, this is a very nasty expression and we won't be able to solve this easily. Okay, so that's a problem. Now what happened here? What happened here? We need to analyze that. When we substituted sine as u, so when we'll take its derivative, you'll get cosine of x in the denominator, and then one factor of cosine of x will get cancelled with this one. It will always happen. And then you will be left with odd power of x, odd power of cosine of x, odd power of cosine of x. Okay? So what we
Mm-hmm.
have to do is, I hope you're able to understand this, right?
Yeah, I'm understanding. I'm just writing.
Okay, okay. So what we are going to do is, if power of sine is odd, like we had in this case, power of sine is odd, this power is odd, right?
Mm-hmm.
If that's the case, then we will use the substitution cosine of x as u. Cosine of x as u. Let me just write the rule. I'm just write the rules here. But we'll do more problems in the next class. I'll just write the rules here. So for this type of integral, if your, let me just change the color. If power of sine is odd, that means if a is odd, if your a is odd, then we are going to do the substitution cosine of x as u. Okay?
Mm-hmm.
Second case, if power of cosine is odd, that means if b is odd.
And then I'm assuming then you take the substitution of sine x.
Yes. Then we'll do the substitution sine of x is equal to u. Then third case can be both the powers are odd. Okay? If both a and b are odd, then you can take either of them as u. Okay? Then you can take either of them as u. Either sine of x or cosine of x as u. Okay? Fourth case could be if both the powers are even. If both a and b are even. Then we will use the half angle properties. So then in that case we will use sine square x as 1 minus cos 2x over 2 and cos square x as 1 plus cos 2x over 2. This is something that we use today as well, but I don't recommend just remembering these things. I want you to understand the logic behind these formulas. So if you want, you can note down this, these four cases.
Yeah. That's what I did. All right.
Okay. So in the next class, we will discuss 4 problems on each of these cases. First case, second case, third case. What happens when A is odd? What do we do when B is odd? And we'll do one problem for each case. Okay.
Sounds great.